All right, let's talk about the properties of inverses. This is probably the most important property of inverse functions. It has to do with composition. It says here that if you take the composition f and you compose it with its inverse and you plug in some value x, that the result should just be x. And here's what's happening there. What we're saying is this. If you have some function f and you have its inverse, then if you plug in some value x over here, it's going to get sent somewhere. We don't know. But when you send it back, where should it go? Well, it should go back to the x it came from. So if you plug x in, goes through, it should come out to be x. And it doesn't matter which side you plug it into. If you started with your x over here, so I'll erase this. If the inverse function gets some value x first, then it comes over here, we don't know where, but when it comes back through f, we should also turn out to be x. So that's why there's two statements, the order here is switched. It doesn't matter, it's like a loop. One does something, the other one undoes it. Now, let's see how that works with a real life example here. So if I were to write the function, we used this earlier, x cubed minus 3, we know that the inverse function we found to be the cube root of x plus 3. Let's just verify the property. Let's just first of all look at f of f inverse of x and see what we get. We should get x as an answer. This means we take f, inside of it we put f inverse of x. Okay, this means we take f. Now what is f inverse? Well, it's the cube root of x plus 3. Now what we're going to do is we're going to take the cube root of x plus 3 and we're going to plug it into f wherever we see x. So we're going to drop the f here. This whole ugly thing is going to go right in here for x. So it's the cube root of x plus 3. But what do we do to that? We cube it. And then after that we subtract 3. So when you cube a cube root, it goes away. You get x plus 3. And now you still have the minus 3. And then the 3's cancel and you just get x. So you can see the property that if you do the composition, then you just get x. Now the property also says we can flip the order. So let me flip the order and show you get the same result. So let's this time now do f inverse of f of x. So this time f inverse is on the outside. Inside is f of x. So that means f inverse, and we replace f of x with x cubed minus 3. And now what we do is we take this and we plug it into the inverse function for x, so it goes right there. So it's the cube root. Now this x cubed minus 3 is this piece right there. Then I still have plus 3. Now the 3's will cancel, and I get the cube root of x cubed, and of course the cube root of x cubed is just x. So that's the property of any inverse functions, is that the composition either way is going to give you a result of just x.